they call this a dimensionless quantity. So go ahead and do the next on your own, number 5. And this is, you're going to be doing the same thing. You're going to take each part and set them up just like this. All right. So now that you've learned to use the equation of the mole fraction, it's time to learn what that means. We talked about this just for a second. It's really just the number of molecules of the gas that you have compared to the whole, okay? So this plays a part with Dalton's law, okay? So remember, Dalton's law tells us that the pressure of the gas doesn't depend on what the gas is itself, just the quantity, how much you have, okay? So if I use the concept of the mole fraction and Dalton's law, I'm going to come up with this. And this tells us that the partial pressure of a gas is equal to its mole fraction times the total pressure, okay? Let's just go ahead and do a couple examples with this, and it'll make sense as we go through that. So the first one says a gas mixture contains 40 grams of carbon monoxide, 10 grams of nitrogen dioxide. If the total pressure is 1.2 atmospheres, what is the partial pressure for each individual gas? Okay, so if we know the total pressure of the gas mixture and the mole fraction of each, we can calculate the partial pressure. That's what they want us to find. Okay, so they gave us grams. That's okay. We've done this so much with stoichiometry, and we know how to take grams of something and change it to moles. So I'm going to do that off to the side. They gave us 40 grams carbon monoxide, and they gave us 10 grams nitrogen dioxide. Okay? So 1 mole NO2 CO. So we just need to figure out what the grams are off of our periodic table. Okay? They did it for us to save us the time right here. This is old news. So this ends up being 1.43 moles of CO, and this ends up being 0.217 moles of NO2. Okay? So that is going to help us come up with the mole fraction. Okay? So I'm going to go ahead and erase this part, keep our numbers there because we're going to need them. So I'm going to make sure I keep track of my labeling. I want the mole fraction for this one, CO, and the mole fraction for NO2. So remember, it's just this portion, so this amount of moles over the total. So I've got 1.43 moles, and I've got 0.217 moles. Now my bottom number is going to be the same. I just have to add these two numbers together, okay? So if I do that, I end up with 1.65 moles. Okay, same here. The moles cancel. This is, let's see, 0.867, and this one is 0.132. Okay, so that is the fraction. So over here, I'm going to say, okay, I need the partial pressure for this, the partial pressure for this, keeping them the same. So let's take this, we know this number now, that's 0.867, and we know this one is 0.132. And we just need to multiply it by the pressure total, which I think they gave us. Yep, they said the total pressure is 1.2 atmospheres, okay? So 1.2 atmospheres. So if I do that, this is going to end up being 1 atmosphere. That's my answer. And this partial pressure is going to be 0.16 atmosphere. Okay? So that's the first one right there. All right, let's look at the next one. So really, we're able to use, we're kind of just interchanging a lot of these things between the total pressure, the mole fraction, and the partial pressure to find these things. We can kind of mix them around. Let's look at the next one. All right, it says a gas mixture contains 456 torr of oxygen, 112 torr of carbon dioxide, and 501 torr of nitrogen. What is the mole fraction for each component in the mixture? So now instead of looking for the partial pressure, we're looking for the mole fraction. So let's put this back up here. P1 equals this times P2. So we're solving for this time. So let's just go ahead and divide here. We're going to move that guy. So really we're taking the partial pressure and the total pressure. We're just going to divide it, okay? So they gave us the partial pressures, okay? They listed them for us. So if I have the partial pressure, let's see, partial pressure is of oxygen. It's going to be 456 torr. Okay. What was the next one? Carbon dioxide and nitrogen. Okay. And the reason why I'm putting this here is because remember, when we moved that, we're left with that mole fraction. That's what we're doing. So the next one, they gave me 112 torr. These are the numbers they gave us for the partial pressures. And down here, 501 torr. The only thing we're missing is the pressure total. So really, we just have to add these numbers, okay? So they add them up, and it's 1069, 1069 torr, torr, torr. So same way, torrs cancel, because remember our fraction, our mole fraction is just a number, it doesn't have a unit. So when I do this one, I end up with 0.427. If I do this one, I get 0.105. And the last one, 0.469. Okay, so these are the mole fractions. So really you can see we just did basically the opposite. We solved for this instead, and we found the mole fractions there. So go ahead and do the on your own number 6 and number 7. And let me know if you have problems with number 7. It's a little bit different. You're going to have to take, they say you produce hydrogen gas over water, so you're dealing with hydrogen, H2, and you're dealing with water, H2O. And they give you a temperature, so you're going to have to take that temperature, the 23 degrees, go to that table, table 12.1, and you need to grab the pressure from there, okay? So I think the pressure, let me look really quick. The pressure for 23 is 21.1 torr, okay? So you're going to grab that pressure, and you're just going to do the same thing here. You're going to rearrange things to solve for, I think you're solving for your mole fraction, like this. So that's where your other number comes from, just be aware, okay? All right, the last thing we're going to learn this lesson is probably one of the most important things from this whole lesson, okay? So it's probably one of the most important things we learn about gases. So we've seen from other modules that it's really important to be able to have the number, to figure out the number of moles of a substance, okay? Usually you can get this information by looking at the mass of something, like grams, okay? But for gases, it's rather difficult to find the mass of gases. It's hard to measure, okay? So it would be nice to be able to relate the number of moles of a gas to things that are easy to measure. So this is where the ideal gas law comes in, right here. This is the last thing we're going to talk about, okay? So it's perv nert. That's the way that we remember it, okay? Perv nert. So in this ideal gas law, we've talked about pretty much all of this stuff. The P is the pressure, V is volume. So pressure times volume is going to equal the N. The little n is the number of moles, okay? So keep in mind, N is just number of moles of the gas. R, I'm going to talk about that in just a second. And T is temperature. So that's great. We've already been working with all these things. We've been dealing with pressure, volume, temperature this whole time. We threw in moles with the mole fraction and all that stuff. Now, R, just like several other things that we've had, we learned about Planck's constant back a couple modules ago. This is another constant. This is the ideal gas constant, okay? And this is an important quantity in chemistry for you to know. So you're gonna have to know this. But the nice thing is you use R so much, the value of R right here, use it so many times that you're gonna already have it memorized by the time you've done several of these problems, okay? So the one thing you need to keep in mind is, remember, when we're dealing with pressures, we've used several different pressures, right? We've used torr, we've used Pascal, we haven't used too many Pascals. We've used atmospheres, okay? So we need to have a way for those units to be represented. So if you take a look, this is gonna be our main, this is gonna be the main one we use in our problems, okay? 0.0821. So this number, you're just going to use it enough, you'll have it memorized, 0.0821. And then we have to include all the units because we know eventually they're going to cancel out. So we have to involve a pressure unit, okay? So for us, we are going to use, well, I'll go in order. So we want to use volume unit, that's going to be your liters. And then we're going to use the pressure, which is going to be atmospheres. And then we are going to do, for moles, that's just moles, okay? And the last one that we use has to be our temperature unit, which is always Kelvin because we can't reach 0, okay? So this is kind of a funky unit. It's got a lot in there. Please include it because you're going to be using it to cancel. Okay, so this is the main one we use because we use each of these units. If you look in your book, there's also other ideal gas constants, other R values, okay? One is 8.315. That one uses pascals and meters cubed, okay? The next one is the same number because it can also be represented as joules over moles Kelvin, okay? So we've used those. So keep in mind that there are other R's as a constant. This is the one we're going to be using. And you can find, this is kind of my cheat sheet of all my stuff in case I forget, it's going to be right here, okay? So let's go ahead and use this we're going to use the perv nert. Oh, and really quick, this, I always say, what the law tells us, it tells us how to relate pressure, volume, number of moles, and temperature. Okay, so this, our constant, we're kind of not talking about that because we really want to be able to relate those 4 things, right? Pressure, volume, temperature, and when it comes to your gas, the number of moles of that gas. So we're using all of the things in our arsenal, okay? All right, I'm gonna erase this because we already have it up there. Go ahead and get rid of that. So look at the example. It says a gas is in a 12.2 liter container at a pressure of 13.5 atmospheres and a temperature of 25 degrees Celsius. How many moles of gas are present? Okay, so this is when it comes in helpful to list everything that you know, okay, off to the side. So we know for perv nert, I'm going to list all the things: pressure, volume, and number of moles.